Wire feeding is a critical part of your robotic welding process. A lot of factors need to be monitored to maintain optimal performance, such as wire feed speed, distance, and friction points within the system. Before you can optimize your wire feeding, you first have to understand the basics of the typical arc process in robotic applications. On the front of your robot is your welding torch. Drive rolls within the wire feeder push the wire through the cable to the front of the robot. Typically, the wire is taken from either a spool or a drum, depending on your particular setup. Your robot's controller will send a signal to the power source of the wire feeder that tells it the speed at which to feed the wire. Drum wire delivery systems, which can weigh in at a few hundred pounds, allow for a larger amount of wire due to their size. This means you'll be changing the wire less frequently. If your application uses more wire, it may make more sense to get a drum so that you aren't stopping production as often to change wire. A spool wire delivery system is easier to manage in terms of size. A wire spool is oftentimes no more than 30 pounds but has limitations to the amount of wire that it can hold. With a spool delivery system, you could have more wire changes, meaning more pauses to your production depending on how much wire you typically use. This leads us straight into the properties of welding wire. Cast versus helix. If you were to pull out several feet of wire from a drum or spool and let it rest naturally on a table, you will see the helix and the cast of the wire. The cast is the diameter of the wire as it naturally sits, and the helix is the vertical height between each end of the wire. Cast of the wire typically won't negatively affect the wire feeding process, but if the helix of the wire exceeds its normal limits, you can experience tangles within the drum or spool, causing the wire to get stuck while feeding. With drums, you need to be aware of the helix of the wire. The way that the wire is tightly wound within a drum can cause a dramatic helix to occur, allowing the wire to twist while being fed. With a spool, you will focus more on the cast of the wire. This is easier to control as you will have a more consistent, straight feeding of the wire. Wire boosters and wire straighteners can help alleviate the problems you may see from inconsistent wire. Wire boosters are utilized to help push the wire over long distances. When you start getting into the 12 to 15 meter range, you will want to consider adding a wire booster into your process. They typically mount to the top of a drum and can be found in both pneumatic and electronic options. Pneumatic boosters have been around for a while, but can cause issues such as marring of the wire and can cause contamination of the wire since you're using air. Electronic boosters provide much more precise support and are a significantly cheaper option. Some, like our Smart Booster, can even collect data around your process parameters, productivity, and can notify you when a supply is getting close to needing a replacement. Let's move to the wire feeder itself. With wire feeders, you can choose between working with a main wire feeder, known as a single drive, or you can combine that system with a support or secondary feeder, creating what's known as a dual drive. Which system you choose will depend on the wire material you are using. When using softer materials, such as aluminum, you'll want to look at a dual drive system with a secondary support feeder being as close to the actual weld process as possible. Let's move on to wire feeding conduits. There are two types, standard conduits and roller liner conduits. A standard wire conduit can be thought of as a tube where the wire simply enters one side and comes out the other side. The smoother that the wire moves through that tube, the better. But with standard wire conduits, the wire will rub against the inside walls of the tube and create friction within the system. The best way to reduce friction within the system is to use a roller liner conduit such as our Master Liner. The Master Liner is made up of small segments, each containing 4 small rollers that spin as the wire passes over them, reducing friction. A Master Liner is best for processes that have prominent bends in the wire feed system, but can be used in any process to reduce friction. Wire feeding plays a significant role in the overall performance of your robotic welding process, so be aware of everything we discussed in this video when assessing your wire feed system. Hey, thanks for watching. Check out some of our other videos, like this one. Don't forget to share your thoughts on this video in the comments below, and subscribe if you want to be the first to see the latest from Abacore Bidsel.